Hey, this is Mr. Masonette, and what we're going to do is practice solving a word problem that involves linear concepts. More specifically, we're going to look at the concepts of slope, the y-intercept, as well as a system of linear equations. So this problem reads that A+ Plumbing and Quality Plumbing each charge a one-time fee and an hourly rate. The table and graph show the total cost each company charges for their services. Determine the hourly rate for each company and the one-time fee each company charges. Also determine when both companies charge the same amount of money for the same amount of time. All right, so if we take a look at A+ Plumbing right here, their information is given in the format of a table. So for 1 hour of service, A+ Plumbing charges a total of $115. For 3 hours of service, $235, and for 8 hours of service, $535. Now, taking a look at this graph, Quality Plumbing would charge $125 for 1 hour of service. They would charge $175 for 2 hours of service, and the rates continue to go up when more time is spent on fixing the plumbing. Now, one thing we should notice right away about this graph is that where this line starts is at 75 on the y-axis. So we would say for 0 hours of service, Quality Plumbing charges $75. Now, one might wonder, wait, that doesn't make sense, but they haven't even worked yet or performed any service. Well, that's where the one-time fee comes in. It's like the company is saying, all right, before we even start to go over to your house and fix your plumbing, we need an upfront payment, a one-time payment. So at 0 hours of service, we still need $75 just to start. So we already know that for Quality Plumbing, their one-time fee is $75. Now the problem wants us to also figure out what the hourly rate is for each company. So right away, we see that we're starting at $75 for 0 hours, and then we go up from $75 to $125, and then over 1 hour. So if we take a look at the rise over the run, or the vertical increase as compared to the horizontal increase, this slope is the hourly rate. And between each point, we go up a total of $50, and we go over 1 hour. So what we're going to say right here is m, which equals the slope, is equal to 50 over 1, which when simplified is $50. And the y-intercept is $75. B is always used to represent the y-intercept. All right, let's go ahead and figure out what the slope is of our table and what our one-time fee is, or the y-intercept. So what we have to do with our table is we have to figure out what is the change in our y values for the corresponding changes in the x values. So if we take a look at 115 and how it changes to 235, we would say that we had an increase of $120. And the corresponding x values increase by $2. So if we take 120 and divide it by 2, that gives us a rate of $60 per hour. Now, we don't have a line here to show us where it's going to cross the y-axis. So here's what we're going to do in this case. Notice that it does give us the total cost for 1 hour, and we already know that 60 of those dollars is the hourly rate. So all we really have to do in this situation is take $115 and subtract 60, and what we have left over is the one-time fee. And that is going to be a total of $55. So the y-intercept, if we were to graph, would be at 55. Now, the problem didn't ask us specifically to create an equation to represent these two situations, but let's just go ahead and do that anyway. So we always start with the output, which is y is equal to, and then we put our slope, which for A+ is $60 per hour, and we would multiply that by x, which is the number of hours, plus that one-time fee of $55. And for quality plumbing, we would say the total cost, or Y, is equal to $50 multiplied by the number of hours plus a $75 one-time fee. Now, what we also have to do is determine when both companies charge the same amount of money for the same amount of time. And what they mean by this is they want us to figure out how many hours of service could we plug into X here for both equations, and we would get the same output or the same total cost for the service. But it has to be the same X and the same Y. We can't have two different X's or two different Y's. We need the same amount of hours that will yield the same output or the same amount of money. Now, there's a couple of ways we can go about this. Let's do the strategy first. What I'm going to do is I'm going to make two tables, one that is A plus, and I'm going to make another table that represents quality plumbing. And what I'm going to do here is start both tables with 0 hours of service. And when X is 0, whatever Y is going to be your y-intercept. Now, for A plus plumbing, we already determined that the one-time cost is $55. So that means before there's any service even rendered, that company is charging $55 for 0 hours of service. Now, if they do complete 1 hour of work, because they charge $60 per hour, we just go ahead and add 60 to 55 because they're charging a one-time fee plus $60 per hour, and that would be a total of $115, which matches up with our table over here. Now, for another hour of service, that would give us a total of $175. For 3 hours of service, that would be another $60, which would be $235. 4 hours would be $295. Now, let's do the same thing for quality plumbing. So for 0 hours of service, the company is still charging a one-time fee of $75. For 1 hour of service, it would be $50 per hour plus the 75, which is a total of $125. For a second hour, we would add another $50, which would be $175. And I am going to stop right there because notice in our table, we have identical X and Y values. So if each company performs 2 hours of service, each of them would charge a total of $175. So that is the same amount of money and the same amount of time. Now, notice in this situation, our answer came up pretty quickly. But let's say you had a situation where you were filling out these tables and the answer didn't happen for a long time, like it was way down here at like 50 hours or something like that. This would not be an effective strategy. So what we're going to do instead of tables is show how to solve by setting up a system of equations. Well, a system of equations is really when you have more than one equation, and we have 2 linear equations right here. Now, if both of them are set in slope-intercept form or y equals mx plus b form as these two are, what you can do is you can take everything after the equal sign for both equations, and you can set those expressions equal to each other. So I'm going to take 60x plus 55 and set it equal to 50x plus 75. All right, now what we're going to do is just solve for x. Whenever you have just one variable in your equation, then it is possible to solve for that equation. So let's go ahead and move this 50x all the way over to the left so we can combine like terms. So we are going to move 50x to the left side, and that results in 10x. And then I'm going to take this constant here of 55 and move it to the other side by subtracting 55 from 75, and that gives us 20. Now at this point, we should know that x equals 2 because 10 times 2 is 20. But just to show our work here, we're going to divide both sides by the coefficient, which gives us x, which is the number of hours, equals 2. And then what you can do is, once you solve for the x variable, you can take that value and plug it into either one of your two equations and solve for y, which would give you the total cost. So we can take y equals 50 times 2 plus 75. And 2 times 50 is 100 plus 75 equals $175. So we can express this answer as an ordered pair as well. We can say our x value is 2 and our y value is 175. Now, what this also means is if we were to graph situation A here, or A plus plumbing, and situation B, quality plumbing, on the coordinate plane, both of the lines would intersect precisely at this point right here, 2, 175.
Hey, I just want to say thanks for checking out this math tutorial. Please don't forget to hit that subscription button and activate notifications so you can be informed as I upload new math tutorials that just might help you with your math homework. Until next time, this is Shane Masonette with Masonette Math.